All right. If you're a data scientist and you're ready to start building real production-level AI systems, then you are in exactly the right place. Today, we're diving into how you can truly master Python for MLOps. We're talking about moving your skills from the lab, from experimentation, into professional-grade engineering. This is the foundation for everything that comes next.
So here's our game plan. We'll kick things off with why Python is the undisputed king of AI. Then, we'll get into its power toolkit, the libraries that make everything happen. After that, we'll see how it acts as a bridge between data science and production, cover 2 rules that are absolutely non-negotiable for any pro, and finally, show you how to set up your environment the right way.
Before we get into all the cool how-to stuff of MLOps, we really have to lock down the why. And in this field, pretty much everything we build, from a tiny script to a massive model, it's all standing on one foundation: Python.
You know, at its core, Python is all about making things simple. It's what we call a high-level language, which basically just means the code reads almost like plain English. And look, that's not just some nice little feature. In MLOps, where data scientists, ML engineers, and other developers all need to be on the same page, that shared readability is what makes everything move faster and more reliably.
And that simplicity, well, it has this massive ripple effect. It's become the lingua franca, the common tongue of the entire world of AI and machine learning. It doesn't matter if you're a researcher exploring some new wild theory or an engineer deploying a model to millions of people. You're speaking Python.
But listen, Python's simplicity alone didn't get it to the top. Its real power, its muscle, comes from this incredible ecosystem of specialized libraries. This is the professional's toolkit that does all the heavy lifting for us.
And this is what makes Python so ridiculously practical. You've got Pandas to wrangle literally any data you could throw at it. You've got NumPy for high-speed math. Scikit-learn is your go-to for all the classic machine learning models. And then you have the heavy hitters, PyTorch and TensorFlow, for building those state-of-the-art neural networks. It's like a whole workbench in just one language.
Okay, so having this amazing toolkit all in one language leads us right to the central idea of MLOps. See, we're not just using Python to build models. We're using it to build a supercritical bridge between 2 very different worlds.
So this is the key question that every data scientist has to answer as they start moving more into an engineering role. Where does Python actually fit in this whole machine learning operations lifecycle? How does it help us get our models out of the notebook and into the real world, reliably and over again?
This right here, this is Python's superpower. On one side, you have that world of experimental data science. We all know it, right? Jupyter notebooks, exploring models, prototyping fast. And on the other side, you have production software engineering. We're talking robust packages, automated tests. Python is the language that lives in both of those worlds, comfortably and effectively.
And here's the magic trick. That messy, experimental code you wrote in your notebook, it's not a dead end. With professional habits, that exact same code can be cleaned up, structured, and refactored into a reliable application. You don't have to translate your work into some other language to go to production. It's huge. Okay, so we've got the why and the what. Now it's time for the how. And if you want to work like a professional ML engineer, there are 2 foundational rules you just have to live by. And these aren't suggestions. This is what separates the hobbyists from the pros. I'm calling these 2 habits non-negotiable for a reason. They will save you from countless hours of debugging, from failed deployments, and from some serious security nightmares. They're just fundamental to building systems that you can trust. First up, rule number 1. Every new project you start must use the latest stable version of Python. Don't cling to old versions just because it's what you're used to. The whole world of AI moves incredibly fast, and the newer releases give you critical performance boosts and, maybe more importantly, security patches that protect your work. And second, rule number 2. Every single project gets its own virtual environment, no exceptions. This is how you avoid what we call dependency hell, that absolute nightmare where you install a library for Project A and it completely breaks Project B. This keeps your work sane, clean, and predictable. So, a virtual environment basically creates a clean, isolated bubble for each one of your projects. It gets its own Python interpreter, its own set of libraries and versions. And that isolation, that's what guarantees your work is reproducible. It means the code that works on your machine will also work for your teammate and, most critically, in the cloud.
All right, let's bring it all home. To actually put these rules into practice, you need the right setup. So let's look at the professional way to manage your Python installations. This is the setup that's going to be the foundation for everything we build together. For a modern workflow, we really recommend a tool like UV. See, older tools handled environments and packages separately, but UV is this incredibly fast, all-in-one solution. It lets you install a specific Python version and manage all its dependencies with simple commands, making sure your development setup is a perfect mirror of what's going to run in production.
So, Python is the great orchestrator. It's the language that bridges science and production. But what happens when you hit a wall? When you need raw, uncompromising speed? Well, that's the next level of MLOps. It's what we call a hybrid solution, where you use Python for what it's best at, orchestration, while calling out to high-performance bits written in a language like Rust or C++. That's how you get the best of both worlds. The real question is, are you ready to become that orchestrator?